now in high school. This is Mr. Ayton, and I want to detail this kinematics problem where we have some constant acceleration and then we have constant velocity. So we have two different things going on. And the best way to do this is to split up your problem into two different problems. The total distance that we're going to cover, this cart A is going to cover a total of 15 meters. Now part of it is going to be constant acceleration. And part of it is going to be constant velocity. And the first thing I want to find in my constant acceleration part of my problem is some information. What was my initial velocity? My initial velocity was 2 meters per second. What was my final velocity? Well, it went from 2 meters per second, and the problem tells us it goes all the way up to a maximum speed of 5.0 meters per second. What else does the problem tell me is that I accelerate. I accelerate 1.5 meters per second squared. It doesn't give us any more information. But if you see, now I can plug this into my constant acceleration equations. I can plug it into Vf equals Vi plus At, in which my 5 is equal to 2 plus 1.5 times time. And I end up finding my time to be 2.0 seconds. I can also find out Vf squared equals Vi squared plus 2Ad, 5 squared, which is 25, equals 2 squared, which is 4, plus 2 times 1.5 times my displacement. And I end up finding that my displacement during this constant acceleration period was 7.0 meters. So I constantly accelerated for 7 meters, which means that my constant velocity was for exactly 8 meters. How did I find that out? Well, the car traveled 15 total meters. 7 meters was constant acceleration. And when we subtract, we end up finding our displacement was 8 meters on the constant velocity. Now there's only one equation we can use for constant velocity, and that's V is equal to D over T. What's my velocity when I am constant is 5 meters per second. What's my displacement? 8 meters. Therefore, I can find the time that it took during the second part of this trip, and the time that it took was 1.6 seconds. The first part of the trip, when we constantly accelerated, we traveled 2 seconds. The second part of the trip, when we were hitting constant velocity, we traveled 1.6 seconds. When I add those two times, my total time is, of course, 3.6 seconds. We know what this graph would look like if I ended up doing a displacement time graph. I would be going a constant acceleration for the first 2 seconds. The next 1.6 seconds, I would be going a constant velocity. And that's this problem. Hopefully it helped out, splitting this problem up into two. Make sure you do this efficiently, and have a good night.